Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hello and welcome back to this amazing channel, Geeks for Geeks Practice. This is Abhinav, DSA mentor at Geeks for Geeks, and today we are again here with our next problem of the day editorial, which is count of subarrays. This stream is quite special for it because we have completed 50K subscribers on our YouTube channel. So thank you guys for this amazing support, and we will be always here for you guys to make you guys more skilled and for you guys to help you with the practice at Geeks for Geeks. So just please, just please write a one if my voice is clearly audible to you all and if I am clearly visible. And then we'll start with the thing. Great, great. So let's start. So the problem today is count of sub-arrays. Okay, and whenever we talk about this problem, like whenever there's a term called sub-arrays, sub-segments, or something like that, not sub-segment, but yeah, subset or sub-arrays. There are some data structures which come to our mind. Let's say we talk about sliding window, we talk about two pointers, we talk about prefix sum. These are the some data structure that come to our mind. But there is another mathematical approach for finding subarrays also. That if we are given with some array and we have to find how many subarrays are there for that particular case, so there are different approaches for finding it too. So exactly, we will be discussing all the different approaches, or basic the most efficient one, because there are some brute force approach, but we will be going to discuss the efficient one only. Okay, that will basically give us the answer in a good way. Okay, that is going to be our approach for this particular problem. Let me first share the screen and explain you guys what how the problem is. Okay, just a minute. Okay, yeah, so great. So this is the problem, guys, which is the count of subarrays, and where we are given with some n positive integers, or basically an array of n is given to us, and we are given with a value k also. We have to find number of contiguous subarrays. So subarrays obviously means where the elements are just continuous. So that is what it is given. You have to find number of subarrays, or we can say value of each contiguous subarray is maximum element present in that subarray. And we have to find all that subarrays. We have to find number of subarrays having value strictly greater than k. So this is what is given to us. So let's first discuss the problem. Okay, and what the problem is. So let's take first a case. Let's take a case that the case given to us is, or the array given to us is. I hope that my board is clearly visible to you all. Okay, I hope it is. It is something like 357. Let me open a chats also so that I can read the chats. Okay, okay. Yeah, great. Okay, just hit the like button, okay? Hit the like button. Great. So, yeah, this is the array which is 3, 5, and 7. Okay. Now, can anyone tell me how many subarrays of this array are possible? How many subarrays of this array is possible? No, it will not be Kadanis. No, no, Soumya. No. Okay. So it will be like 3, 5, 7, 3, 5, 7, 5, 3, 5, and 7. Let's say this is the subarray. Okay. These are the subarrays. Obviously, you can see that these are the subarrays which are given here. Okay. So they are basically something. It's something 2 to the power n minus 1. So if n elements are there, so the number of subarrays are like this. Okay. But there will be duplicates also in this case, so we can change it also. It will not be like this because in this case I can say that duplicates will also be there. To avoid that thing, we can say it like that the total number of subarrays will be n into like this. Because in that case we will get subsequences, but here we are talking about subarrays. No, I have not missed 3,7. Joel, we are talking about subarray. 3,7 is a subsequence. If I will talk about subsequence, I can say 2 to the power n, but here we are talking about subarrays. So for that, no, it's not. It's this only, which is n into n plus 1 by 2. If I'm talking about subsequences, then that will be the case. Is it clear? Okay, fine, great. Now, so basically we can say that for array containing n elements, we have n plus 1 by 2. So how this is basically happening? So let's say that we have four elements in our array. Let's say our array is like 2, 3, 4, and 5. Okay, let's say these four elements are there. So if I will ask you that tell me the different number of different subarrays that we can have. Okay, so subarrays are like key. We have to take a point, we have to take the start point of the array, and we have to take the end point of the array, and the elements between them are basically is our subarray. Okay, so what we have to do out of the given array, we have to do two things. We have to find its start point and its end point. Okay, or we can do it in a different way. Okay, let's see how what that different way is. So let's say if I will first take this 2, it will be something like this 2. This is a single subarray. Okay, if I will iterate till this, there will be two different subarrays that are possible. The first will be 2, 3. Second will be just 3. So for till here, one subarray was possible. Till here, two Subarrays are possible from here. The first possible is 2 comma 3 comma 4, then 3 comma 4, then 4 only. So 3 Subarrays are possible. Then till here 5 Subarrays are possible. Oh sorry, 4. Like this. 2 comma 3 comma 4 comma 5, 3 comma 4 comma 5, 4 comma 5, and just 5. So it's something sum of first n natural numbers, which is nothing but n plus 1 by 2, which is nothing but n plus 1 by 2. Am I clear? You can go through this again. You can go through this part again. It's not a very advanced thing. It's a very medium level thing. Okay, great. Uh, just the sum of first and natural numbers. Okay. Exactly. Okay. Great reset. Now we have to find the maximum from each subarray. The maximum from each subarray means we have some different subarrays. We want maximum from each of it. So the maximum of first subarray is 3. It is 5. It is 7. It is 5. It is 7. It is 7. Okay. Now what we have is we have to output those subarrays which are having maximum. So this is called, we are calling it as a value. This is the value of a subarray. So we are targeting those subarrays which has value greater than k, strictly greater than k. So let's say in this case our k is 4. So how many subarrays are there whose value is strictly greater than 4? Tell me this thing. There are five such subarrays. 5. 1, 2, 3, 4, 5. So for k is equal to 4, our answer is 5. Okay? Great. Now, the next thing. Okay. Now, the next thing. Let's say our answer is 5. Oh, sorry, our k is 5. So for k is equal to 5, we want those subarrays whose maximum is greater than 5. So only these 3 will be the answer. The answer will be 3. Yeah, we just hit 50k on practice. So thanks to everyone for your support, guys. Means we arrange different sessions on this channel, this practice channel, and we basically made make efforts for you guys that if we are making some efforts, if we are planning some lives, if we are planning some streams, so that is just for you guys. And what just we want from your side is your support. If you guys are there, if you guys are supportive, then it that is what all we want, and that is what we get also. And thank you very much, guys, for this amazing support to this particular channel. And we have crossed 50k subscribers, and it was just I think before this stream, and hope we will to cross the 100k 1 lakh subscribers, and we will get a silver play button soon. So just the only thing requires is the support from you guys, and we will be always there for you guys to make you learn. Okay, great. Let's again to the question back. Okay, great. So we have 777. This is what we will do. Okay, now no, it's not a sliding window. Yeah, and obviously we have uploaded 1k 1000 plus videos on this channel, and means a channel is itself a different we can say a library of DSA videos. You will get each and every topic in this particular channel. We have more than 1000 videos in this each single channel of GFG practice. So it's really amazing, guys. Okay, great, yeah. So let's continue. Okay, yeah. So just a minute. Great. So now for finding this, so guys, we will follow the path of reverse engineering. Okay, we will follow the path of reverse engineering. Now, what is reverse engineering? Instead of finding the subarrays whose value is strictly greater than k, we will find those subarrays whose value is less than equal to k. So if I can find subarrays whose value is less than equal to k, and if I can subtract it from the total number of subarrays, I will get the answer. So let's say if I will ask you that for this case only, tell me how many subarrays are there whose value is less than equal to 5. So you will say that there are 3 such subarrays. 1, 2, 3. And how many total subarrays are there? There were total 6 subarrays. So 6 minus 3 is 3. And you can see 3 is the answer. So we will find the method of reverse engineering. Now, the next case, guys. How we can find how many subarrays are there whose value, or we can say how many subarrays are there whose value is less than equal to k. So now I will focus on only those subarrays whose value is less than equal to k. Means whose maximum element is always less than equal to k. Always. Now, the next thing, guys. The next thing is, let's take a larger example for understanding this, okay? Let's take an example. Let's take my phone number. Yeah, obviously it's not correct, okay? I just skipped the repeated digits, okay? That's what. So yeah, these are some numbers, okay? Now let's say that we have to find those subarrays, okay? Let's say our value of k is 6. It's 6, okay? Yeah, it's not correct, Subham. So it is 6, okay? So now what we want those values whose value we want those subarrays whose value is less than equal to k, will not exceed k. Okay, so we will discard those elements whose values are greater than k. That is fine, Joel. There will be 36 subarrays. Okay, that is what we have got it. Okay. Now listen one thing. Okay, we can write that, yeah, there are 1, 2, 3, 4, 5, 6, 7, 8 elements. So total there will be 8 into 9 by 2, 4, 36 subarrays will be there. So I can say that total 36 subarrays are there. Great. Okay, but how many such subarrays are there whose value is less than equal to k? So guys, we will just iterate from the start. So we will be here. Currently the value is 9, which is greater than k. So as I told you, we want those subarrays whose value is less than equal to k, not greater than k. I will discard this 9. I will not take this 9. I will continue. Next is 3. Yeah, we can take 3. Next is 5. We can take 5. Because 3 and 5 are less than k. Less than 6. Next is 8. So we will discard it. But before discarding 8, we have 2 such elements that are contiguous also. Contiguous means we can make subarrays from it. And how many subarrays can be formed? Just tell me, if you have 2 numbers, from that 2 numbers, how many subarrays can be formed? What was the problem? The formula was n into n plus 1 by 2. So for 2, it will be 2 into 2 plus 1 by 2. 3 subarrays will be formed. How 3? एक हो जाएगी 3, 5, 3,5. Great. Okay. So from this number, 3 Subarrays are formed. Now we have 8, so I have just break the logic. 8 cannot be taken. Again, we have 4. It is less than equal to k. We will take it. We have 6 less than equal to k. We will take it. We have 0 less than equal to k. We will take it. We have 3 numbers. Those are less than equal to k. Again, 7 is greater than k. We will not take it. But because we have 3 numbers, from these 3 contiguous numbers, we can take the subarrays. Again, 3 into 4 by 2, 6. So from these 3 numbers, 6 subarrays can be formed. So total 9 such subarrays are there whose value is less than equal to k. Total there were 36 subarrays. 9 are those whose value is less than equal to k. So how many subarrays are there whose value is greater than k? Can you tell me? Write a one. How many subarrays are there whose value is greater than k? Hit the like button. We have 20 viewers. Hit the like button. Yeah, there will be 27 subarrays. 36 minus 9, 27 subarrays are there whose value is greater than k. Let's implement this thing. Let's implement this thing. Okay. Let's take a count. Initially, it will be 0. This count will store such numbers whose value is less than equal to k. I will simply iterate for all the elements of the value n. Okay. Okay. Let's take it as long because long LL is already defined here. That long is defined as LL. We can simply take that because the value will be maybe large. Okay. Maze cut, the results are being evaluated. We are basically checking it. Okay, because there are some formalities, there are some process, and after that we will have a post where we will say that who are the winners of that 30 days history. After getting the logic, this question is no longer reserved to be 4 marks. Exactly, Shubham. I think that logic is the most important part for a particular problem. If you will appear for an interviewer will expect the logic from you. If you have come up with the logic, then he or she might can know that yeah, you can implement a solution. But the most uh, difficult thing is the logic, getting the logic, how the problem is to be solved. Okay, great. Now, guys, if the value of ARR of I is greater than k, if it is greater than k, so what we will do? We will not count it. But let's have an answer here. Or like means basically this answer will store the subarrays whose sum is less than whose value is less than equal to k. So whenever we have a ARR greater than k, so we will have, so let's say here k we have greater than k, greater than 6. So for the rest of the two values, we are having number of subarrays and we are adding it to the answer. So we'll add the value of c into c plus 1 divided by 2 into the answer. And then we'll make c is equal to 0. Okay, inside it only. In the else case, if the answer is, the else case is that if our answer is less than equal to k, I will do, okay, make it c, count plus plus. At the last also, if count is let's say greater than 0, so we have to add to the answer. Okay. Yeah, no worries. And after that, as I told you, we have to delete it from the total. So if I will take a LL total, it will be nothing but n into n plus 1 divided by 2, and answer will be total minus answer. And we will just return the answer. Okay, so for the first case, we have got the solution. Let's submit it. Okay, okay. ये क्या है भाई? Uh, uh, so should we have to return the answer in some? For 85 digit number, I think you should prefer string. Otherwise, big integer should be used. Okay. There is some problem, guys. Let me just see. Uh, hmm. So I think it is the problem which we are having in that case only, uh, which is it is getting overbound. But because we are taking it as a long, I don't think it should be given overbound. And they are also not given that we have to output the value in, we can say, by taking something. Uh, or what if we can just directly return this value without storing it in total? Maybe that will give us the answer. Let's see this thing. That can might be the solution. Okay. So there's one more case that we will take this as also long. This n. Okay, yeah. So guys, the problem was, let me say the problem. The problem was that when we were multiplying this n with n plus 1, okay, what our program was expecting. So whenever we multiply two databases, it gives the answer in that only. Okay. Yeah, here we don't have to take modulo actually. That's the case. We don't that is what I was expecting. But we have to try it and we have to basically debug. So this n should be given in the long only because we have to make the multiplan. That should be. So it was getting out of bound of the int range. Okay, but we are writing in it in long. That was the case. So I've just taken that int in a long, and that was the only thing that happened. Okay. So guys, yeah, that was the problem. I hope you have got this problem. Explain. So initially c is equal to 0. So let me tell you that, let's say this is the case. Okay, let's say this is the problem. So what I'm doing here is, let me first erase it. What I'm doing here is that initially c is 0. We will go here. It is greater than k. We will not take it. It is less than k. We make c is equal to 1. Less than k, c is equal to 2. Again, c is great, k is greater than k. We will take pairs. We will see that whenever the value is giving greater than k, we are adding it to the answer, and that is what we are taking here. Then next is less than k. So now we will again make c is equal to 0. Then again c1, c2, c3. Again c is equal to 0. Whenever we will find a value less than k, less than or equal to k, we will increase the c. Otherwise, we will make it 0. Okay. If we talk about the time complexity of this problem, it is nothing but order of n. Okay. And the space complexity is order of 1, because we are just iterating. Okay, and we are not using any dynamic space. The space is just constant. Okay, so this is the problem. Okay, this was the problem, and this is how we can implement it. It was a basic line number 30. Okay, then okay, let's take that at the last. Let's say we are calculating this thing. At the last, we don't have any large value, so it is adding c in the answer whenever we are getting a value which is greater than k. Then only it is adding the c in the answer. Let's say there is no value greater than k. Let's take that there is no value at the last which is greater than k. So how we will add that value in the answer? For adding that value in the answer, we have to do it from here. At the last, whatever, if the c will be 0, so obviously it will not add any value. But if c will be some value, it will add it. Okay, that is the case. Fine, and we have got the right solution for it. Okay, guys. So again, thank you very much for this particular session. I hope that this is clear to everyone, and you guys have got this particular problem. Keep solving the problem a day by Geeks for Geeks. And once again, thank you very much for the support to this amazing channel. And soon we will reach 100K too. And thank you guys. Thank you guys. Thank you very much. Good night. Have a good day for tomorrow. Happy coding. GFG कर लो, हो जाएगा.